Alright, given a graph, write a quadratic rule. Obviously you can see this is a parabola, so we're going to have a quadratic rule. And if we can see the x-intercepts, we should be able to use those as well. So I'm going to start with that, and you can see my x-intercepts are 0, excuse me, negative 3, 0, and 2, 0. So I know that I can have x plus 3, that's where I get 1, 0 from, and x minus 2. Alright. Now the thing we gotta keep in mind is there's lots of parabolas that go through those two intercepts, but we may need to multiply by something to get this one. So I'm gonna pick a point on here, and actually the y-intercept can help us here. If I plug in 0 for x, I should get 18 for y. And if you do that, if you notice something here, I get, this comes out to be negative 6. Well, I need to get 18. Well, so that means I must need to multiply by a negative 3 out front. Alright, and actually that'll work, and they want it in standard form, so I have a little bit more work to do. This is in factored form, so what you'd want to do is do a generic rectangle and turn that into standard form. I think we'll do that quickly here. I'm going to multiply my two binomials, x plus 3, x minus 2, I get x squared, I get negative 6, I get 3x, negative 2x, so I get y equals negative 3 times x squared plus x minus 6. And then I just need to distribute the negative 3 to get my final answer. So y will equal negative 3x squared minus 3x plus 18. So there's my final answer. Same thing can be done here from table form. I have, here's one x-intercept. So remember, you get an x-intercept when the y value is 0. I have the y-intercept here, but I don't have the other x-intercept. So you have to use the fact that parabolas are symmetrical. So if you take a look at this, you can kind of tell here's right here at negative 1, negative 4.5 is the middle. Because you can see we're going 3.5, 0, negative 2.5, negative 4, negative 4.5. So it bottoms out right there, then it starts to go back up. So if you want, just extend the table here. And the next value here would be 0, 2, 0. And actually, there it is. We just had to stop right there. We could keep going 3. The next one would be 3.5, but we got what we wanted right there. So our other x-intercept is 2, 0. And we do what we did on the front, or on the first one. X plus 4, x minus 2. You can pick anything here. Usually if you have the y-intercept, that usually works nice. So when you plug in 0, this simplifies down to negative 8. Well, we need to get that to negative 4, so we need to multiply by a half, or 0.5. Alright. And then we want it in standard form again. So we get y equals 0.5 times x squared plus 2x minus 8. And distribute. And there we go.